Hello and welcome. My name is Kent Rohr. I'm the sales engineer for Maxmatech. In this video, we're covering the SDK STM IDE Cube and TouchGFX on the demo application, reviewing the keypad module within the SDK, how to utilize the keypad, different functionalities, all within the demo application. So first, I'm going to show you what kind of documents we're working with. Go to maxmatech.com, products, CAN bus products. Click on the 430. Scroll down to documentation and downloads. Here you'll see the 430 Design Studio software guide. This is for the SDK. We'll be referencing some information in here. You can find more details of code snippets and breakdowns of all the functionality of the keypad as well within this guide. I'm going to pull up the IDE. In this workspace, I have the 430 SDK project file demo. And where to find that, if you don't have it already, is in the download section here. Go down to demo project file, download that, and open up in your IDE as we've referenced in previous videos on how to open up project files. In the IDE, we look at the very top left in the project integration folder. In core Maxmatech user modify files, we have some files here that may be referencing for the keypad functionality and other platform services modules. So right now, I have the 430 config file open here. If you scroll down to around line 240, this goes into the keypad module configuration. So we're going to review the module configuration first. Then we'll look at the demo application on the .cpp file for the main view and the IO view screens. And I'll show you in TouchGFX kind of how it correlates with the code and the GUI. So in this keypad module configuration, you define the SDK service keypad as if you want to enable or disable. Within here, you have different kind of task priorities. Now, these task priorities are different depending on how you want to utilize them, but the priority none is basically just no priority. There's nothing initialized. And the priority idle, that's just reserved for an idle thread. The priority low would be just the low priority. And we jump down to low 1, that's the low priority plus 1. So 1 under the low. And then the priority ISR, that's just reserved for the ISR deferred thread. And the priority error, that's where the system can't determine the priority. It's an illegal priority operation. So you can reserve that under error. If you're trying to find if there is going to be an error within the system, navigating through the keypads and selecting. And then priority reserved. Priority reserved is going to be where it prevents the enum, the enum downsize compiler and how it's optimized. So typically, whenever you're doing any of these kind of demo sample applications that we're talking about, you'll see either none, idle, or low priority that we're utilizing through this code. Now the priority idle task priority here, we've got a configuration state of the keypad backlight on or off, as in a 1 or a 0. So you'll define this within your C++ code that you write within your files as far as what priority that you want it to be sitting idle at for a backlight on or off. This next part here is the backlight configuration state. So key backlight on, short press timeout in milliseconds. So at a 10 millisecond short press is the max, is how the short press will function. And then when we set the keypad backlight on, that is then referencing down to the timeout. Your configuration state is 1 and 0 for enable and disable. These are all things that you can modify as far as on or off. And then we have some defines here for 4 keypad states, 1, 2, 3, and 4. Next, I'm showing you the user-defined.h file. That's in your core Maxmatech user modify files. user-define.h. This is important because you're going to see some defines for the different key 1, 2, 3, and 4 on the states of being active, short press, long press. There's even a continuous press. So these are the ones that you're going to be referencing within your code as far as how that user is pushing that button and then what's going to then happen as a result of pushing that button. Now let's look at the source mainView.cpp file. You're going to find that from project integration, go all the way down to TouchGFX GUI, down to source src main screen, and source mainView.cpp file. So having that open, looks like this file here in the demo project file. Starting up from the top, we have included this file, which we just talked about, the user-defined file. And when we scroll down here a little bit, you'll see that we're referencing that we're going to be starting in key position 1. You have multiple positions. You can start the key position in. And for this first part of the program, which in TouchGFX, when we look at the main view, this is what it looks like, and you're in key position 1. Going down a little bit lower here, we go through the setup screen, the teardown screen, and then we have key update. So this is where we're going to define the key update, which is the uinteger8_t value. And this is something you'll see in a lot of the project files. So we're defining here that if you have key 1 and it's a short press, key 1 long press, and this is what's going to happen. Move previous, move next screen, move back screen. So this is the functionality of the keys, how they're going to be updated for this screen here. Now you see on this screen here, there's not much functionality as far as what you're using for the keys. So this light sensor is automatically being updated through the light sensor and showing data. Engine speeds being pulled through CAN. And voltage input is through input and just showing it here. So the actual keypads are not toggling through anything here. You're just going to be going back, forward within these screens. Now if we look at the I/O screen, there's a lot more happening with the keypad. In this keypad, you can go back to the previous screen. You can go to the next screen from keypad state 1 to 4. But then 2 and 3 has lots of different options for how the keypad state can function. And so you can select, say, one of these toggles, and then you want to go increase or decrease as far as turning up, turning down, turning off, turning on within these states. So we're going to look at some of that code within the IDE for that. So here I'm going to go to src_io_view.cpp. That is going to be your CPP file in the TouchGFX GUI source IO view main screen. So I'll show you that here. We're in GUI under TouchGFX, going down to source, going down to IO screen, view.cpp. Now this section, we'll look at the very top first. You're going to see that we're calling out on the view part of the screen setup that we're going to start in key position 1. When we scroll down here, now we're setting up our uinteger32_t position for the key position, and then we're stating keypad 1 or long, move previous, else if key 2 short press equals value. And then we're going to a few cases. So if you look back at TouchGFX, you've got back and you've got next, but then we've got a few cases involved with these keys 2 and 3, which will have different states that can be toggling different values or turning on or off different switches. So let's look at the switch position of the key for case 1. So if we have the config digital output off or on, then this is going to actually change the GUI side of the TouchGFX. And you'll also see that we're changing the state of the actual button there, the widget of GUI on or off as well. So you got two cases there. We do a break and then we go to case 3. Now case 3 then jumps into some other features of that screen, like the LCD and the brightness. But when we look back at this case 2 section here, and we talk about how we want that GUI updated for the toggles to be on or off, you're going to see some more of that code as we go down lower. So I'm going to go all the way down to the mid 300 line. Now here we're sitting at line 365 of the same file. We're still in the key update section of this string of information that we've coded out for the keypad updating. Now back to digital output on line 365. Now if it's enabled, if the output is off or on, now we're going to do a setDL function. Now a setDL, there's two different ways to call the DB layer field and get functions within this SDK. So there's a function name of getDL and setDL. Now the getDL is when you as a user can use the API to retrieve the value of the data from the database. The field ID is defined from the database.h file, which then identifies the data field that you'd be interested in. So that can cover the U integer 16 underscore T, the DL index, the U integer 8 underscore T buffer. And then there's the setDL. And the setDL is when the user can use the API to store the value. So remember, get is to retrieve, and then set is to store the data from the database. And that field ID is defined by the database.h file as well, which identifies the data that you'd be interested in. Same with the integer values, 16, 8, your DL index, and your buffer. You can find this information all in the manual on page 71 for the 430, which I'll show here. So on page 71, it's talking about the DB layer for the user APIs and the function names that you're calling to get. So now that we've talked about setting and getting, you're now seeing a set here. So now we're actually going to set this toggle for whether it's going to be on or off. So it's going to store that value. So here it says setDL, and it's calling the digital output 01 state and set. If it's already on, then it's going to set the output 01 config state. So this is doing a toggling of what you see in the GUI here. The top left, two toggles here. Now, when you scroll down past what we just talked about here in these two sections for the low and high side, setting the state of on or off, you're going to now see some cases here talking about the different inputs and how to set them. So in the TouchGFX, the GUI side on this page, you'll see digital, resistance, frequency, and current. When you go back to the IDE, you'll see we've got the current here, setting it depending on different states, 1, 2, 3, and 4, and 5. And if you scroll down further, then you've got the resistance, how to set it, and this is all still within the keypad section of this code. And then you got the configure input for frequency. And then we got a break, and if else if, then key forward, short press, long press, move back screen, which you'll see here is the next screen or to go back. So that's the functionality. So you're going back a page, forward a page, but once you start getting into these toggles and through the scroller toggle, and then to these buttons actually get highlighted through TouchGFX on the GUI side. When you're in these, that's when you're moving back and forth between in these through different cases and you're changing the states. through that set DL. And then when you get down to the very end, then you can get back out. Now, when we're talking about TouchGFX, navigating through the toggles, the scroller, and then the different buttons for the different inputs, and you want TouchGFX GUI side to be able to show that text or that button of where you're actually navigating through the screen. That's where you're seeing in the same file. I just scrolled up to 172 line. You'll see where we're setting in the key position and the different cases for going through each button or toggle or switch, and how those are going to be highlighted or colors or the text are going to be set, showing in TouchGFX as you're moving through these and selecting on or off. If you're selecting digital, how that's going to be highlighted or in bold. So that's all that functionality is within these cases here. On the key position for the cases, all the way down to 8 different cases. And you'll see 1, 2, 3, 4, 5, 6, 7, 8 cases for all 8 here. Now we've been looking at the source CPP files within TouchGFX GUI. Also show you on the HPP side, on the include files. You'll see here that the main presenter, so the main screen, I might go into main. This screen here under .hpp, you go down here a little bit and you'll see that we've got a virtual void key update, the uinteger8_t value. So we've called that out because we're actually using that within the source file of the CPP. In the IO screen, with all those toggles and buttons, you also see a virtual void as well for that, because we're actually calling out that functioning, that class, and it's going to be a virtual void because this is already built in within the SDK through TouchGFX, the whole architecture of the software, and so that's why it's going to be a virtual void rather than a void. Now let's do some quick sample code, just showing kind of what we've already looked at. You'll see this also in the manual, some breakdowns of this as well. But let's say that we want to do a keypad function sample code where we want to set or get the backlight using the key 1. So if we're going to do that, I'm going to show you a snippet of code that would accomplish that type of functionality. So here we're saying if key 1 short press equals value, then we're going to take the state of the keypad backlight on. We're going to set the keypad backlight to the state. And then we've got the get DL keypad backlight state. That's where we're now getting the backlight state. So we're changing the state, we're getting the state. Another example of a code snippet that we can do where we want to look at the key status and how to read that status and acknowledge it. By doing so, reading the keys read status lets you know if the keys are active or inactive. So there's a DB entry that has to be read first for receiving the key press event. And if you receive that it's active, then the user could then read the key press, say key press 01 DB variable. That's checking the state of the key press. And then from reading that key press, you can continue to monitor that. You can change that and so forth. So here is a little bit of code snippet that we'll look through. So here, we're going to proceed if we have key 1 is active. So we have if key inactive for the key status. So we're going to get from the DL the key press 1 status. And if the short press for the key status is 1, active, then we're going to set the DL key status. If it's a long press key status 1 active, then we're going to set the DL, acknowledging that key press for that key. So here, looking at this code, understanding C++, but not possibly understanding TouchGFX and how that correlates within the ID and how to write it out using our SDK. I'm going to show you the manual of kind of a breakdown of how that information flows. So this is in page 76 on the keypad read status. So you're going to see here the different field IDs, the key status 1, 2, 3, and 4, the data type, the permission, the size of the byte, if it's active or inactive, the description, and the comments here. So for the first one, the field is to use to read the status of key 1. So this is to read the status. And then here we're changing out permission. Now we have a read or write function on these 4 different keys. So you're reading the key press, then you can then change that. So you can set DL. So you're going to detect the type of that key press for, say, key 1, and then you could do a set to then set the key status. And that's what this code right here is doing, which we showed here. So there's more examples in the manual of how to use the keypad functionality and how you want to utilize that for other types of platform services and modules. You'll see just in this demo application itself, they're using the light sensor and changing the LCD brightness, but you can also use that within a widget of TouchGFX to turn up and down the brightness of the LCD, or turning off or on the backlight through the keys itself with buttons on TouchGFX. There's lots of different ways that you could try to utilize the keypad on just a short press, long press, continuous press style. But now that you know you've got the 430 config.h file and the user modify files under core maxAI, you can take a look at again, going over the keypad. You have seen in the main and the IO view of different functionalities of how the keypad's been used. You've seen some demo sample snippets that you also find in the manual around the page 70 to 80 part, which covers the keypad module section of that platform service. On later videos, we'll be covering all the other types of platform service modules in detail. Again, thank you for reviewing the keypad functionality for the SDK on the 430. My name is Kent Rohr, the sales engineer for maxAI. I'll see you on the next video.